In our last video, we have learned about hydrocarbon, which is inside petroleum. So for hydrocarbon, that means the compound with carbon and hydrogen only. Now, under complete combustion, okay, so both of them will become the oxides. So carbon will become carbon dioxide, and hydrogen under combustion, okay, with oxygen supply, it will become water. Now, if there's not enough oxygen supply, then what will happen? If oxygen is not enough, then not less oxygen will be contained in each carbon. In other words, instead of carbon dioxide, carbon monoxide may be formed, or maybe carbon itself will be formed if there are not enough oxygen. So that's why in the picture you can see for incomplete combustion, carbon monoxide and carbon will be formed. Now let's watch a video to learn more about the combustion of hydrocarbons.
In this video you are going to learn what combustion is, the difference between complete and incomplete combustion, the products of the two types of combustion, and the effects of the products of combustion. Combustion is burning, usually in air which is all around us, or oxygen. It's an exothermic reaction, which means it gives out heat. A fuel stores potential energy that can be released as heat when we burn the fuel. An example of a fuel is natural gas or methane. This is the fuel we burn to heat up our food. Methane, like other hydrocarbon fuels such as petrol, can undergo either complete or incomplete combustion. When methane undergoes complete combustion, that is in a plentiful supply of air, it produces carbon dioxide and water, as shown by the equation CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas. When methane undergoes incomplete combustion, that's in a limited supply of air, it produces either carbon monoxide and water or carbon and water, as shown by the equations 2CH4 gas plus 3O2 gas gives 2CO gas plus 4H2O gas. CH4 gas plus O2 gas gives C solid plus 2H2O gas. Now the effects of the products of combustion. Water vapour, as we all know, is harmless. Carbon dioxide is a greenhouse gas and contributes to global warming. Carbon monoxide, however, is toxic. It's colourless, odourless, tasteless, and so is called the silent killer. Carbon monoxide is often produced by faulty gas appliances. That's why it's important to have your gas fires and boilers regularly serviced. Unburnt carbon is a particulate and is a pollutant in the air. So, to recap, combustion is burning, usually in air or oxygen. Complete combustion of hydrocarbons produces carbon dioxide and water. Incomplete combustion produces either carbon monoxide and water or carbon and water. And the products of combustion have various effects.
Okay, so now we can write down For combustion, no matter it's complete combustion or incomplete combustion, it will be an exothermic reaction. That means it releases heat. But the idea is that complete combustion, of course, will release more energy. Because let's have a look about the product from incomplete combustion. Actually, these two are fuels. They can be further burned to give out more energy. So that's why incomplete combustion actually has some energy haven't released. So it releases less energy, okay, under incomplete combustion. Now during complete combustion, hydrocarbon react with oxygen to form carbon dioxide and water. Now I think there is a difference between the what video mentioned and in DSE. So we will expect you to use L to represent the physical state of water form. Maybe you just wonder, how come under high temperature water shouldn't be in gaseous state? Now in reality, for physical state in the product side, we will consider its physical state in room temperature. So maybe under combustion is gas, but after it cools down, it will become liquid in room temperature. So I write down L. Now let's have a look about how to balance combustion equations under complete combustion. So let's say, for example, now it's a bit difficult, so please use your pencil because we may need to change your answer later on. You may not be able to get the final answer in one step. Now for this one, now just ignore, okay, how to name it. It actually is called butane, but at that moment, the naming is not important. So it's called C4H10, so 4 carbon in one molecule. When you react with oxygen in complete combustion, it will form carbon dioxide and water. And now we have to consider, now for this part, you better use your pencil. So let me also change my color pen. So firstly, we balance it by looking at the number of carbon. So 4 carbon on the left hand side, so 4 carbon dioxide will be formed on the right hand side. And next we look at hydrogen. 10 hydrogen on the left hand side, so there will be 5 H2O formed. And lastly, we count the number of oxygen on the right. So there will be 8 plus 5, that means 13. So 13 oxygen atoms, so it will be 13 over 2, O2. So there will be 13 on the left also. However, we don't like fractions to be occurred inside the equation. So how to do that? How can we eliminate the fraction? Then we can times 2 to the whole equation. It means that I have to rewrite the equation. Firstly, this one, 1 butane, so you have to write down 2 because it times 2. And the next one is 13 over 2, so now is 13. So for CO2, it will become 8. And 5 H2O will become 10. So that's the idea. The next equation, again, it will form CO2 and H2O. Liquid, remember. So again, I use my pencil. So 6 carbon dioxide with 7 H2O form because 14 hydrogen is required. Now count the number of oxygen on the left, on the right. So it's 12 plus 7, so 19. So 19, so it will be 19 over 2. Again, it's a fraction, so we have to times it by 2. So it will be 2, this is what we call it as a hexane, and 19, and 6 will become 12, and last one will become 14. So that's the idea. However, under incomplete combustion, carbon monoxide will be formed. So in the video, we also learned that actually carbon monoxide is toxic and is called the silent killer. So now let's do the checkpoints. You can stop the video to try the checkpoint yourself before you check with me. Which of the following is not a product of the combustion of fuels? So it will be B, very obvious. Question 2. Which about the incomplete combustion of octane is incorrect? Firstly, it's exothermic, that's correct. Even for incomplete combustion, even though the energy release is less compared to complete combustion, but it still be a exothermic reaction, so it's correct one. B, it produced carbon dioxide as one of the product. Okay, so we had to stop at that point, okay, to come back again. And then C, it happened when oxygen supply is not enough. And D, the flame produced is yellow in color. What do you think? B, C, D, which is incorrect? So most likely it should be B, okay? Because the carbon dioxide should be formed in complete combustion. The flame produced is yellow, again, is because of the carbon, okay, particles. Do you remember I mentioned about it in the previous video? Because carbon particles, okay, formed under incomplete combustion, right? It formed carbon particles, right? And it will grow under heating, just like the charcoal grow when you are barbecuing. So question C, why is it extremely dangerous to use charcoal? It's a grill, indoor, with all windows and doors closed. So why is it dangerous to do so when you are burning charcoal? So burning charcoal, if you close door and windows, so what will happen is there will be not enough oxygen. And not enough oxygen will cause incomplete combustion. And what will happen is that carbon monoxide will be produced, and it's a silent killer. Understand? So carbon monoxide will bind with the hemoglobin, and then your hemoglobin cannot carry oxygen very well, and finally you will die because of the shortage of oxygen. So next one, greenhouse effect. So from the previous video, we learned that actually for combustion of hydrocarbon, it not simply produce carbon dioxide and water, okay, and carbon monoxide, something toxic, and it also produce some other problems. One of the problem is greenhouse effect. Greenhouse effect, okay, can be caused by the combustion of fossil fuel. So do you know what is greenhouse effect? 温室效應. And do you know what is greenhouse gas? 温室氣體. In our previous page, we learned about carbon dioxide form, okay, by complete combustion, right? So even though we just mentioned about carbon monoxide is toxic, but carbon dioxide is also not something very good. If there are too much carbon dioxide released into the atmosphere, carbon dioxide is a kind of greenhouse gas. So for example, carbon dioxide. So we introduce more, okay, in the next slide. So to understand more about greenhouse effect, let's watch a video.
And the moon are basically the same distance from the sun, yet temperatures on the moon average an unlivable -18 degrees Celsius. And even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays.
Let me stop a bit here. So for some of the molecules, they are able to absorb the infrared radiation from the sunlight. Okay, so you just need to understand that. So how they can absorb infrared radiation is not the main point in this video.
For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder.
Okay, so now we understand how greenhouse gas trap the energy because they have the ability to absorb the infrared radiation. So let's have a look about your notes. The idea is like that. When sun's radiation pass through the atmosphere, but of course some of them cannot pass through because of the atmosphere. So when they pass through the atmosphere, they will reach the surface of the Earth. And then, of course, some of the energy will be lost into the space, but some of the energy will be trapped inside the atmosphere because of the greenhouse gas. So that's why, okay, there are some keywords, okay, we can tell your highlight pen and mark it down. Firstly, infrared from the sun, okay, infrared from the sun. Let me use my laser pointer. So infrared from the sun, okay, most pass through the atmosphere and it will be absorbed by the Earth's surface. And for greenhouse gas, it works like the glass of greenhouse. They will absorb some of the infrared radiation, re-radiated from the Earth's surface and trap the energy. What's the meaning of re-radiated from the Earth's surface here? If we have a look at the previous slide, okay, so as you can see, energy pass to the Earth's surface, and part of them will re-radiated out. So for this process, why they can't go into the space is because that greenhouse gas absorb it. So they absorb the radiation re-emitted from the Earth's surface. So that's why now this part is very, very important. You better tell your highlight pen and highlight this one. Okay, very, very important. Yes, being asked in public exam. So there are some examples of greenhouse gas as you can see from the video. For example, carbon dioxide, okay, water vapor, or methane. And the others just like CFC, chlorofluorocarbons, okay, N2O dinitrogen oxide. Okay, this is not for CFC, you will learn about it later. So most importantly in this chapter is about carbon dioxide and water. Carbon dioxide and water come from complete combustion of hydrocarbon. How about methane? Where do we get methane? Do you still remember one of the fossil fuel. So for example, natural gas. Natural gas contains mainly methane. So for natural gas, if we use it as a fossil, as a energy source, so some of them may not be burned and they will release into the air. And even for the extraction of natural gas, some of the methane gas will be escaped into the atmosphere. And now I give you some special, very interesting news about the source of US methane emissions. The first one comes from natural gas. Okay, it's not that surprising. But the second point comes from animal digestive gas. What's the meaning? And then the third one is landfills. Now, I would like to have a look about animal digestive gas. Just like this cow. Now, we found that for the digestion of cow, so bacteria, okay, when they try to break down organic substance in the food, they will convert part of the organic substance into methane. So that's why for the digestive gas comes out from the cow, okay, from that side or at that side, they will release into the air. Do you know that from a cow, okay? So for one day, it will release around 500 liter of methane. That's so much, right? 500 liter of methane per day from one cow. So that's why you can find that animal digestive gas actually contribute a lot to the methane emission. So if there are too much greenhouse gas come to the atmosphere, it will cause the enhanced greenhouse effect. So enhance 加速咗啦. What will happen is temperature just increase so lot, and finally the ice cap will melt and increase the sea levels. And also it will change the climate and decrease the food production. So I think this is also important. So mark it down using your highlight pen probably. So that's why we think there is necessary to find the alternative energies that can produce less carbon dioxide and methane. So people try to find the other alternative, just like solar energy, hydroelectric energy, that means use water to produce energy, like tidal energy, wind energy, or even nuclear energy. So here, what's the meaning of energy from biomass? So let's have a look about this one, okay? So for example, animal residues, okay? And as you can see, what's that? Agricultural residues, example, because they are organic substance. So by using some bacteria, we are able to break it down into smaller carbon compounds, which can be a fuel, okay, which can be part of the fuel. So we'll learn more about biomass in your grade 12. So not simply carbon dioxide, methane, etc. come from fossil fuel. If we burn fossil fuel, actually there are much more air pollutants that will cause. So we will introduce it one by one. Now, firstly, I introduce something that is easy to be understand. For example, carbon monoxide. So you know it comes from incomplete combustion, right? So let's write down because of the incomplete combustion. And it's so poisonous, okay? It may even cause death. And then the second one, it will be this one, the unburned hydrocarbon. So what's the meaning of unburned hydrocarbon? Hydrocarbon is inside fossil fuel, right? Unburned, that means you haven't burned it. But because hydrocarbon, maybe we don't have enough oxygen, so you can't burn it. Or maybe because it's simply vaporized, because some of the hydrocarbons has low boiling point, so it can be easily vaporized. So the main cause causing the unburned hydrocarbon to form is because of the incomplete combustion. So not being burned, but it just come out. So if the unburned hydrocarbon goes into the atmosphere As you know, some hydrocarbon, for example, those aromatic hydrocarbon, it can be carcinogenic. That means it may cause cancer. And also it may cause a situation called photochemical smoke. Smoke 啲煙嘅意思，煙啊。So actually this picture is a picture, okay, with photochemical smoke. So photochemical smoke caused by different factors. The first factor is because of the unburned hydrocarbon, and also is because of the nitrogen oxides, as I will introduce it in the next one, the third one. So unburned hydrocarbon with nitrogen oxides and then maybe with sunlight, finally together, they will work together and cause photochemical smoke. But detail about photochemical smoke is very complicated. We are not going to introduce it in this chapter. And then for nitrogen oxides, how does it form from hydrocarbon? Now for hydrocarbon, theoretically there's no nitrogen inside, right? So how come burning fossil fuel will form nitrogen oxide? So let's have a look about this picture. Firstly, do you still remember what are the main components in the air? It should be nitrogen and oxygen, right? So nitrogen and oxygen actually come from the air. So let's say we have, can you draw it in your notes? So if this is the car internal engine, so when petroleum is being burned here, okay, so you know that you need oxygen to burn the petroleum, to burn the petrol, okay? So for oxygen in the air is necessary for petrol to be burned and can release energy to drive the car, right? So not simply air will pumped into the internal engine to burn the petrol. At the same time, because air contains a lot of nitrogen, it will also goes into the internal combustion engine. So part of the oxygen will be used to burn the petrol, but part of the oxygen will combine with nitrogen. So a combination of oxygen and nitrogen in the air in the internal combustion engine. Now, very important, can you tell your highlight pen? It should be under high temperature. So under high temperature, oxygen and nitrogen will combine and become nitrogen oxide, nitrogen monoxide. So 2 nitrogen monoxide. Nitrogen monoxide, okay, is colorless. So this colorless gas, okay, very important. Can you follow me? This one. So nitrogen monoxide will further react with oxygen in the air. It means that when nitrogen monoxide comes out, okay, so because the air contains oxygen, so it will further react by this equation. Sorry, I don't have space, so I write here NO gas plus oxygen. So it will become nitrogen dioxide. So write down in your notes. Nitrogen dioxide is a brown gas. Okay, it's a brown gas, so you mark it down. So it's also very toxic. So we'll introduce more about nitrogen dioxide in chapter 20. Okay, but probably we'll teach it in grade 11. So understand how nitrogen oxides form. One way is that it because of oxygen and nitrogen in the air enter the hot internal combustion engine, and it change into nitrogen monoxide, and nitrogen monoxide further oxidizes in the air to become nitrogen dioxide. So remember, for the second equation, it's happened in air. It's not happening in the internal combustion engine. Okay, this one is in air, so probably I write it better. This one. Okay, so now for nitrogen oxides, they are toxic, and they are quite irritating. They will irritate the respiratory system. And then here I missed one word. Nitrogen dioxide, okay, is about nitrogen dioxide. Nitrogen dioxide gas will dissolve in rainwater to form acid rain. So I think you learn about it in Unit 13, rusting. So there will be a reversible reaction, HNO3 nitric acid, and at the same time a weak acid, HNO2, will be formed. Okay, so water is L. So remember, it is nitrogen dioxide, okay, react with water to form the acid rain. But actually, nitrogen monoxide converting into nitrogen dioxide is a super easy reaction. So you can't stop nitrogen monoxide to change into nitrogen dioxide. It must be happen in the air. And to remove these three different kinds of air pollutants, including unburned hydrocarbon, carbon monoxide, and nitrogen oxides, then there is a same way to remove them. It is called installing the catalytic, write down, converter, yes, converter. Okay, catalytic converter, write it down. So TER is TER, not TOR. So we just install it in motor vehicles, okay, not in other places. Catalytic converter is installed to the cars. So what is catalytic converter? Let me show you, okay? There is a video about it. Okay, maybe I show it a bit later. Okay, wait here. So to understand catalytic converter, do you mind turn to page 14 of your notes? So let me introduce catalytic converter first before we fill up the other blanks. So catalytic converter in the motor vehicles look like this. So later on I'll show you a video how catalytic converter works. So this is the inner part of catalytic converter. So for carbon monoxide, okay, unburned hydrocarbon and oxides of nitrogen, once they pass through the catalytic converter, they will change into the carbon dioxide, water, and nitrogen. So carbon dioxide is less harm compared to carbon monoxide, is much better. And carbon dioxide actually is a natural substance existing in the atmosphere. So remember, it's not an air pollutant, although it will cause greenhouse effect. So but it's not an air pollutant, not, okay? Because it's naturally existing in the air, so it's not a pollutant. And for catalytic converter, now let's have a look about the video before we move on. It's quite a long video for around 4 minutes. You better mark down some important points in any spaces in your notes.
Luckily, each car also has a catalytic converter. Located under the hood, attached to the motor, right before the exhaust system. Gases produced by the motor go straight into the catalytic converter and come out the other side less than 1/10 of a second later. The converter gets less than 1/10 of a second to recombine toxic gas molecules and produce harmless substances like water vapor and oxygen. How? To understand it, we've got to destroy it. The stainless steel housing contains 2 ceramic blocks. Each block is filled with thousands of microducts. Their sides are coated with precious metals. Precious? Platinum and rhodium in the first block. Platinum and palladium in the second block. Metals that can cost more than $100,000 a pound. But they're worth every penny. Together, they have the extraordinary property of causing toxic gases to react and then recombine, producing gases that are harmless to your health. All that without altering themselves or rusting. Precious. The trick is to maximize the contact zone between gas and metals. That's why there's so many microducts, almost 400 per square inch. Their combined surface area matches that of a football field. A laboratory as big as a football field, but folded onto itself in order to remain small. The transformation of gas from toxic to non-toxic happens most efficiently when the catalytic converter is hot. Very hot. 1,300 degrees Fahrenheit. It's the toxic gases themselves that heat up the catalytic converter. They exit the motor at temperatures as high as 900 degrees Fahrenheit. The chemical reactions inside the catalytic converter also generate heat, transforming the converter into a super efficient furnace designed to break down and reform gas molecules. Let's take a closer look at these mysterious transformations. The nitrogen oxide and carbon monoxide molecules, along with the molecules of unburnt fuel residue, enter the catalytic converter. They're swallowed up by the thousands of microducts. As they reach the platinum and rhodium in the first block, nitrogen oxide molecules are the first to react. These metals break down the molecules by withholding one of their atoms. The freed atoms stick to each other and recombine. The result? Nitrogen oxide molecules become oxygen and nitrogen, which already make up 99% of the air that we breathe. The gas molecules now head into the second block, where the microducts are coated in platinum and palladium. These precious metals withhold oxygen. The intense heat here forces the carbon monoxide molecules to combine with the oxygen. The result? Carbon dioxide, the same gas that creates bubbles in soft drinks. Now for the molecules of unburnt fuel residue. At these extreme temperatures, their encounter with the oxygen forces them to recombine. The result? More carbon dioxide and water. All that in less than 1/10 of a second. In theory, the catalytic converter can eliminate 99% of a motor's toxic gases. In reality, it's inefficient as long as it's not hot.
So now you should understand more about the catalytic converter. So remember, it is this three become the less harm product. So there are three types of catalysts inside the catalytic converter. Do you still remember? They are the expensive metal, but in the video it said reverse it. So they include platinum, okay, and then rhodium, and last one is palladium. So this our as catalyst 催化劑啦 to facilitate the conversion. So usually, as you can see from the video, okay, the metals are coated in honeycomb shape. So why? First one is easy to understand, is to increase the contact surface area. Right? And that now your metal just need to coat a thin layer on the surface of this the whole catalytic converter. So that's why it can reduce the amount of catalyst used, because you just need a thin layer to be coated on this honeycomb shaped substance. So now, how's the conversion? For carbon monoxide, you remember what's the product it become? It become carbon dioxide, right? And then for nitrogen monoxide, it become the most abundant gas in the air, which is nitrogen gas. So it's not balanced. So there should be, let me see, there should be 2 carbon dioxide. Yes, okay. And the next one, for carbon monoxide, it may also combine with oxygen. Do you remember in the video there are single molecules of oxygen? So the second way is that carbon monoxide bind with oxygen directly to form carbon dioxide. So carbon dioxide have two ways to form. And then here is just an example. If there are any unburned hydrocarbon, let's say hydrocarbon with more than 5 carbons in each molecule. So because of the oxygen, do you still remember? A lot of oxygen will be provided in the second chamber in the catalytic converter. So they will be easily become carbon dioxide and water. So remember, water is L. And then you try to balance the equation. Actually, I give you some hints, right? So 2C8H18, so there will be 16 carbon dioxide, and then 13 hydrogen on the left, so you need 18 water. So you can try to balance the whole equation yourself, okay? But we want to save the time. So now you understand how catalytic converter works, right? Now then we can go back to our notes. So can you now turn to page 13. So the fourth type of pollutant is suspended particulate. 一啲懸浮粒子啦。So they may be the unburned hydrocarbon, they may be simply carbons which form under incomplete combustion. So they may be hydrocarbon or carbons themselves. So this particulate 一啲懸浮粒子啦 they are quite large in size, so that's why we call it particulates instead of molecules, okay? So they form because of complete combustion again, and they may irritate our respiratory system, and it may also reduce the visibility. That's easy to understand. So how can we remove the suspended particulate? Suspended particulate mainly come from power station. So there is a device, okay, stored in power station, which we call it electrostatic, okay, precipitator. Okay, 靜電沉電器啦。So what's the meaning? So now, as you can see at the bottom of this page of your notes, so if there is a flue gas 即係廢氣，唔係 fuel gas 啊。Okay, 廢氣。I just forget about how to. 廢字 is it like this? 呢度痰啫。I forget how to write the Chinese word. Okay, so flue gas is 廢氣, not fuel gas. Okay. So for flue gas coming out from the power station, so probably they will contain a lot of suspended particulate. And how to remove it? Firstly, can you see there is a negative charge wire here? So when flue gas pass through the wire, they will carry negative charge. And can you see there are two plates which carry positive charge, right? So what will happen is the flue gas particles, they will now carry negative charge, and they will be attracted towards the positive plate. So if there are more and more particulates attracted to the plate, and then they will accumulate, and they will just settle here. Can you see the dust tray here? So they will just settle there. Understand? And then, so that's why we can move on. The last air pollutant is sulfur dioxide. Sulfur dioxide, then think about hydrocarbon inside fossil fuel. How come there's sulfur dioxide? Do you think sulfur dioxide formed just like nitrogen oxides from something in the air? Now this is not the truth. Actually, for petroleum, there are some impurities. Certain amount of sulfur is inside, so sulfur as impurity. So what will happen is when we are burning the hydrocarbon, sulfur is also being burned. So by adding with oxygen in the air, it will become sulfur dioxide. Now, among the three kinds of fossil fuel, coal has the greatest amount of sulfur. Some of the petroleum, if they are low grade, then they also contain certain amount of sulfur. So here I just want to remind you, natural gas compared to coal and petroleum actually has less impurities. So it will give less sooty flame, and also it will give less air pollutant. So if sulfur dioxide, because when you dissolve in water, do you remember, it will form an acid, okay, which is called sulfurous acid, which is a weak acid, and this is acid rain. So sulfur dioxide, whenever it contact with water, it will become something acidic. So that's why it will irritate, okay, our respiratory system and eyes, because there's water, there's moistures. And how to remove the acidic sulfur dioxide? First way is by installing something we call it scrubber. What's the meaning of scrubber? So that is the idea. Now, because sulfur dioxide is acidic, okay, so you can write down in your notes. So that's why we have to react it with something, for example, alkaline, for example, carbonate. So usually we use calcium carbonate to react with the acid. So if calcium carbonate reacts with sulfur dioxide, calcium sulfate will be formed. So this is the product. And it can further convert it into calcium sulfate by oxidation. So detail we won't learn about it. But calcium sulfate, okay, is an important construction material. So that's why we can convert some waste into something useful. At the same time, we may use calcium hydroxide, because calcium hydroxide is also a base, okay, which can react with sulfur dioxide, which is an acid. So understand, scrubber means we use something to neutralize the acidic air pollutant. So that's why this method can be also applied to remove, let's say, chlorine gas, let's say HCl gas, okay, these kinds of acidic gas. And also another way which we can reduce the emission of sulfur dioxide is to use some fuel with low sulfur content. Actually, in Hong Kong, since 2007, so government, okay, require the fuel to be with very, very low sulfur content, let's say 0.001%. So that's why, can you tell your highlight pen? We can assume something that for the fuel for cars, because of the super low sulfur content inside, we can assume there's no sulfur dioxide gas coming from the combustion of petrol in cars. We can assume no sulfur dioxide, okay? So now, let's have a look about the checkpoint in the last page. Probably I forgot to mark it down in my PowerPoint. So just wait. Okay, so we work together. So I give you some time to read the question yourself. You can stop the video and think about the answer yourself. So now let's have a look about the first question. Which of the following statements concerning dark smoke in car exhaust gas in Hong Kong is incorrect? A. It contains sulfur dioxide. B. It contains mainly carbon particles. And it can cause serious lung disease. And it can reduce visibility. So if there's dark smoke, it means that there's incomplete combustion. So that's why B, C, and D are all correct because of the particles and some of the carbons, etc. But for A, it contains sulfur dioxide, it should be wrong. Because as you remember from 2007, the fuel used in car, we can assume there's no sulfur. So it doesn't contain sulfur dioxide. That's why the answer is A. Okay, so you better mark it down. Okay, next question. Question 2. Carbon dioxide and oxide of nitrogen produced by vehicles do not stay in air. So, which of these statements describe one way that both of these gases are removed in the air? So, why carbon dioxide and nitrogen oxides are not in the air? Answer is, I think it's quite obvious. It's B, because they can be soluble in the rainwater. Carbon dioxide, when it dissolves in water, it will become, let me write down, it will become carbonic acid. And nitrogen oxide, as you remember, it will become nitrous acid and nitric acid. Okay, this two. Question 3. Which of the following changes occur in a catalytic converter installed in a motor car? That means what happened in catalytic converter? Sulfur becomes sulfur dioxide? No. Okay, it can't be used. Carbon dioxide become carbon monoxide? It should be the opposite. Okay, it should be the opposite. Okay, unburned hydrocarbon change into carbon particle? It should be wrong. It should be carbon dioxide. Okay, instead of carbon. And nitrogen monoxide change into nitrogen. That's correct. So answer is D. Question 4. Which cannot reduce the emission of air pollutant from a coal-fired power station? So it's a coal, right? Coal contains quite great amount of sulfur. So remember these three inside. A. Installing scrubber. So this is correct because it can remove the acidic sulfur dioxide. B. Installing electrostatic precipitator. This is also correct because it can remove the unburned hydrocarbon and some of the suspended particulates. Remember, coal is difficult to be burned, so unburned hydrocarbon and also the carbon particulate will be huge amount. C. Increasing the height of the chimney. This not. It can't help. And then last one, use fuel with a lower sulfur content. So that's correct. So if coal with lower sulfur, then less sulfur dioxide will be formed. Last question. Which of the following is not a major source of sulfur dioxide? Coal-fired power station is yes. And then factory, yes. Volcanoes also produce quite a lot of sulfur dioxide. So this is new to you, right? But small size of car because they use petrol. So it's no. Because petrol with no sulfur. Okay, but very little, we can assume no. So that's the end of the second video. Okay, please make sure your notes is tidy.